With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. So there are two statements which have been given in the problem, and we need to check whether the statements are true, and if true, whether statement 2 is correctly explaining the statement 1. Now in the first statement it is given that there is a vertical rod which is having coils of wire wound over it at the bottom end. So this is basically a rod. Okay, at the bottom end there are some coils which have been wound. Now there is an alternating current which is flowing in the coil. Now this rod goes through the conducting ring as shown in the figure. So this is our conducting ring. The ring can float at certain height above the coil because so it can float at certain height. So whether we need to first of all say whether this is right or wrong. Now in the above situation, a current is induced in the ring which interact with the horizontal component of the magnetic field to produce a average force in the upward direction. Now for example, let us suppose that this coil is basically there is alternating current which is flowing into the coil. Let us suppose that the current enters from this coil, or if we just make the coil the cross-sectional view of this coil, the bottom coil we are just saying. Let us suppose that the current is flowing in this direction in the bottom coil. This is the bottom coil. Okay, bottom coil. Now what will happen? So we can see that there would be since it is an alternating current, so this value of the current would be changing. So due to the change in the value of the current, there would be a changing magnetic field which would be developed. So if we view from the top that the current is flowing in this counterclockwise direction. Okay, this is the counterclockwise direction. So what would be the direction of the magnetic field? From the right hand rule, right hand thumb rule, we can say that magnetic field would be going in the upward direction. That means in the conducting ring it would be passing like this. Okay, so due to the increase of the magnetic field in the upward direction, what would this ring try to do? It would try to have a current so that it produces a magnetic field in the downward direction. How can it produce a magnetic field in the downward direction? Now if the coil have a counterclockwise magnetic field, in this example counterclockwise, then magnetic field is in the upward direction. So what should be the direction of the current into this loop? So we can say that the direction of the current in the coil we just make here, so it should be, if we view from the top, it should be in the clockwise direction. This is the top coil. This is the top coil. Okay, that means the current should be going in this direction. Okay, now for example at an instant of time, okay, let's say this is the direction of the current. Okay, and there is also a horizontal magnetic this field that would be developed due to this coil. So we say that, let's say this is our horizontal magnetic field. Okay, now what would be the direction of the force? If we just represent this in 3 dimensions, we say that this is the situation is like this. We are just making for the conducting loop. Okay, the situation is like this. So basically this is our conducting loop which has been placed. So the current is going in this direction. Okay, magnetic field is in this direction. This is our I, this is our B. What would be the direction of the force? We know that force is F equals to I L cross B. Okay, so this is in the vector form. We just write it in the vector form. Let's say this is our X, this is our Y, and this is our Z. Now if we just represent what is the direction of the force, if we just find the direction of the force, where is the force occurring, whether it is occurring in the upward direction or down or left or right, so we can say that it would be the direction could be given by L cross B. Now what would be the direction of the length element? We just calculate the cross product. It would be in the minus k cap. So we put the value as minus k cap. We are just calculating the dot product, minus k cap cross. What is the direction of the magnetic field? It is in the minus I cap. So minus and minus would be positive. K cross I is equals to J. That means the force would be acting in the upward direction. That means on this conducting loop, the force is acting in the upward direction. So what will happen? If the force is upward, directing upward, if it balance with our mg would be acting downward just at the center. So we say that if F is equals to mg, then we can say that it would be balanced or it could float at certain height. And it is why possible? It is only possible due to the horizontal this magnetic field, and it produces a this average current in the upward force in the upward direction. So we can say that statement 1 and statement 2 are correct, and it is correctly explaining. So A is the correct option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.